Welcome dear all students for the session 12 of the subject system software. So now we are dealing with the unit number 2, and in that today we will be discussing the subtitles, that is statement of the problem and the data structures. So in the previous class, let us have a recap. So in the last class you have understood the introduction, general design, procedure and design of assembler. So with that introduction for the general design procedure and the design of the assembler, let us today start learning some of the important concepts of our assembler. That is, today's learning objective is to understand the statement of problem and the data structures we are using in the design of assemblers. So the session outcome of today will be the student will be able to understand the statement of problem and the data structures. So let us start with the statement of the problem. So during the design of the assembler has to do the following. The first one is the assembler will continue to work in two phases. One is pass 1 and pass 2 there. So in the slide you can make out that the different operation which are doing, we have represented whether it is occurring in the pass 1 or pass 2 or both in the pass 1 and pass 2. So the first thing here is to compute the location counter. So this is very important to start the assembly process. Next, it scans for the errors. This is also accomplished during the pass 1 there. Next, it will produce some of the instructions wherein first it evaluates the mnemonics in the operation field to produce its machine code. Pass 1. So in the last class, you have learned the different mnemonics like add, sub and so on. Then it evaluates the subfields. It finds the value of every symbol, processes the literals and assigns the addresses. Doing all these things will be done in both pass 1 as well as in pass 2. So next it processes all the pseudo ops or the directives which comes into the process of execution, which has been done in both the pass 1 as well as in the pass 2. So totally we can group all these tasks into two passes or sequential scans over the inputs. And here they are connected with each task or one or more assembler modules. So now let us see what's happening in the pass 1 and the pass 2. In the pass 1, the purpose is to define the symbols and literals and determine the location counters, as we have discussed in the previous slide there. So for doing that, the first thing what the assembler is going to do is it will be going to scan the syntax. Then it will find out the length of machine instructions, and this is available from the table called as machine operational table. We have seen in the assignments in the MCQs of the previous slide, that is MOT, that is machine operations table. Then a track of all the location counters using variable location counter. Then it produces symbol tables with address or value of a symbol which is been obtained from the symbol table. Then it will memorizes all the literals, and these literal table can be combined with your symbol table for doing this task. Then it processes some of the directives like EQU equals begin, origin, start, EGM and so on. Then we have to construct an intermediate version, a file or a structure to which will be used during the pass 2. Then produce the data for data or number, skip and literals which can be generated from data gen. So in the pass 2, the purpose is to generate the object program. So here it will observe the addresses of the symbol using the symbol table, then produces the instructions from the MOT, the table what you have discussed. Then it produces the reports for the user, produces the object file intended for the linker, and then on to the simulator. So now let us see the data structures which will be used in pass 2. So when coming to databases, you should have an input source program. Then the location counter utilized to maintain the track of every instruction's location. So once we got the location counter, then machine operation table MOT signifies the symbolic mnemonics for every instruction, and its length may be between 2, 4 or 6. Next, the directive or the pseudo operation table will signify the symbolic mnemonics and action to be taken for each pseudo operation in the pass 1. Symbol table is used to mask each label and its equivalent value. Then we use the literal table, which is utilized to amass each location. An accurate copy of the input is saved for the pass 2. This may be accumulated in a secondary storage device like disk or in a structure, or it may be in a main memory. In a primary or secondary memory. So that's about the databases for the pass 1. Once they are done in the pass 2 databases, first they have to copy of the source program. So this is done with the knowledge of your pass 1. Then the same thing we are using the location counter followed by MOT, that is machine operation table, which signifies for every instruction. So mnemonics, what is the length, what is the binary machine opcode, and the format they are using, whether it is RS, RX or SSI. So next, the directive or the pseudo operation table that signifies for every directive the symbol mnemonics and the action to be taken in the pass 2. The symbolic table organized by the pass 1 comprising each label and its corresponding value. A workplace, that is instruction INST, is to hold every instruction as different parts. For example, binary opcode, register fields, length fields, displacement So finally, an output file of assembled instruction in the format needed by the linker will be generated. So that's about the data structures of our pass 1 and pass 2. So let us have our MCQs regarding today's session then. First question for the MCQ is, the instructions like MOV or add are called as what? So you have the options OP, opcode, operators, commands, and none of the above. I think for this it is opcode, that is operation code. Next, second is the last statement of the source program should be stop, return, end, or none. So it is end there. So when you're terminating your source program, you should terminate by the keyword called as end. Next, in 2-pass assembler, the task of the pass 2 is to do what? So first one is separate the symbol, mnemonic opcode and operand fields. Option B is build the symbol table. Option C is synthesize the target program. Option D is none of the above.